Hello everyone. In our previous video, we have shown how to model our scrap tear rubber pad isolator. Right now, we have to define our material properties. So go here, material properties, and click New, Standard. First, we have to define the rubber properties. So write rubber. It is better to give the name. Then the mass density is 1. If you see from the PDF, I will give it in the description. 1.522 inverse 6. So 1.522 inverse 6. Then you have to define some model for rubber model. For rubber, there are some model. If you go here, so there are some money model, Ogden model, Aruda Boys model. So in this tutorial, we are going to use the money model, or you can go for Ogden or the voice, etc. But for this tutorial, we are going to use money model. So for money model, there are some constant. If you Google it, we will get the theory of money model, and you will get the strain function, and it has some constant C10, C01, C11, and these constants are taken from the paper of the PhD thesis work of Humakanta Mishra. So in this paper we got the value, so we are writing this one here. So the values are 0. This one, so let me write this one. And the last one. Okay, then we have to define the viscosity properties. This one, there is 2 terms, and this one is 5 terms. This one is 0.2, 0.55, 0.3, 0.3, and this one is 0.1, 0.25, 0.5, if I'm not wrong, 0.5, 0.75, and 1, and this one is 0.4, 0.25, and this one is 0.15, 0.1, and 0.05. Okay, you can search in Google, and you will get the extensive details of Brownies series. Okay, now you have to also define the damage effect. So click here. So this one is 1. These values are also taken from some papers. This one is 0.01, if I'm not wrong. 0.01, yes, and this one is 0.05, this one is 5, this one is 10, and this one is 0.5. Click OK. So we have defined all the properties of the rubber. Right now we have to enter these properties into the rubber. So click here, elements, add. So we need to click the rubber here, but it's so congested here, and the carcass layer, bale layer are also here. So as we defined the sets earlier in our previous video, so it is easy to click the sets, not the elements here. So if you go here, this one, this is called choose currently defined sets. So if you click here, you will find the sets that we have created before. So if you click rubber, then you can see the rubber element has been added. You can also define, you can also check from here also. Go to material properties and click identify. Again, you can see the rubber properties have been imprinted. Okay, let us define also the steel properties. So steel, the mass density is 7.56 E-6. The EM modulus is 200 megapascal, and the Poisson's ratio is 0.3. Okay, we don't have to add the elements right now because the carcass layer, the well layers, the river orientation is not same, so we are not defining here. So then go to here, river, first carcass, the element type will be membrane, click append and still. So you can see this is rivers per length. So as we go here, so okay, you can see there are two rivers and the spacing between them is 0.4 millimeter according to Homakanta Mishra's paper. So we can say there are 0.4 millimeter the spacing. So we can say there is one river at 0.4 millimeter spacing. Okay, so river per length equals to, so the number of river, how many rivers? One river. So here is 1 and the spacing is 0.4, so you have to write 0.4 here and you will get 2.5 here. Okay, so this is the river per length, 2.5 per millimeter. So if we go to Marc Mentat, look, rivers per length, so this one should be 2.5. Then the river area for the carcass layer was, and you can see the diameter of the carcass layer is 0.2, and if you calculate the area, then you will get 0.44, and the carcass layer has no angle, so it will be 0. So add this one, this set, this is carcass, and you have entered the carcass one. Okay, so let us define the belt, other one too, belt 1, belt 2, belt 3 and belt 4. So river belt 1 membrane append still, this one is 2.5, and the area is, if you calculate the area of the belt layers, you will get 0.63, and the orientation is 72 degree. In the radial tear, the belt layers are oriented at 72 degrees and minus 72 degrees, so it will define it here. So click add here and choose belt 1 and click OK. Same goes for belt 2. And this, the angle should be minus 72. Click add and belt 2. Okay, you can copy this one, as this one is identical for the belt 1 and belt 3, and belt 2 and belt 4 are same, so we can copy this one and just change the name. This is belt 3 and add here and choose belt 3. Click OK. Okay, and the last one is belt 4, which is same as belt 2. Click add and belt 4. Okay, so we have defined all our material properties. We have to check all the materials are correct or not. So go to set, let us remove the rubber part first, then go to identify, and you can see there is the legend. You can see this is the carcass and this is the carcass. Belt 1, belt 1, if I zoom it, carcass, belt 1, belt 1, belt 2, belt 2, belt 3, belt 3, belt 4, belt 5, and you can match the color if anything is wrong. all the colors are same. So okay, so we have defined all our material properties here. Let me channel. So in the next video we'll show how they are connected. So we will have to define the contact area. So until then, see you in the next video.